All right, let's take a look at this question here. We've got y equals x squared minus 2x minus 3. We're going to sketch this, and then we're going to determine the equation of the result when this parabola is reflected in the y-axis, in the x-axis, and then in both axes. So let's find the intercepts first. The x-intercept is when y equals 0. We're going to factorize this here, and then we're going to solve. So these are my x-intercepts. We can find the y-intercept when x is equal to 0. Y-intercept is -3. Always nice and easy to find a good y-intercept. We can also find the vertex. Now, the vertex can be found in a few different ways. We're essentially going to look at what we've been doing in class, which is the completing the square method. So we are going to halve -2, which is -1, and square it to get 1. And then we are going to -1 and -3. Keep that -1 there. This becomes a perfect square. And then we have my vertex form. So now that we've got the vertex form there, let's begin to sketch this. So we're going to sketch this parabola. I'm going to do a nice large, wonderful sketch. So we've got that there. We're going to then quickly -3, -2, -1, 1, 2, 3, 3, 4. Alright, there we go. So let's do the first sketch first. So we've got 1 minus 4. Oh my god, there it is down there. So here's my parabola. We know it's got intercepts at -1 and 3. So let's quickly draw my parabola. There it is. Now the first thing the question asks us to do is it asks us to reflect in the y-axis. Now it's important to know that a reflection in the y-axis is essentially what we are doing is we're replacing x with -x. Or you're finding f of -x. So the new function that I'm essentially finding is going to be -x squared minus 2 -x minus 3. That would be the equation of my new function. But we can see here that a reflection in the y-axis, what it's going to end up detailing is that a lot of my different parts of my curve, they're going to be the same side of these axes as here. So essentially, my new turning point, if I'm reflecting it over this y-axis, the vertical axis, this is going to be the equation of my new turning point. You can see if I swap I'm going to be swapping these intercepts over. Now, the big part about this is that the y-intercept will remain the same when you reflect in the y-axis. That's a really important note to make. And there it's going to end up being there. We can see it's a reflection in the y-axis. We can find the equation of this graph. The equation of this graph is right here. -3, yeah. So we replaced x with -x, and that's what we ended up with. So there we can see the difference. Or, pardon me, we can look at just by reflecting these different points over the y-axis and know that if we're reflecting over the vertical axis, the coordinates must be the same distance apart. That's 1 unit there. That's 3 units there. It will work essentially the same way. Let's see if I can go back a little bit on those, but I don't think I can. There we go. So it doesn't look as messy. Now the second part is a reflection. If we scroll back up, it's a reflection in the x-axis. A reflection in the x-axis is a reflection over the horizontal axis, over the x. It makes a couple of larger changes. The main thing to know is that essentially what you're doing is you're replacing y with -y. So what my function becomes is, if this is my original function, then and it's y equals, then it's essentially becoming -y is equal to x squared minus 2x minus 3. If I times both sides by -1, I end up with y equals -x squared plus 2x plus 3. A different equation already. Now we can find all the information from my new equation and plot it Or we can know that a lot of these are going to have, it's going to be similar, but a little bit different to my original graph that I had right there. What's going to be similar about it is a reflection over the x-axis. That point is going to need to be the same distance above. It's going to be sitting up there. The y-intercept is going to be the same, it's just the y-coordinate is negative, and it will have the same x-intercepts as the graph that we had before. So when we're reflecting, we can make a little note of this. I'll use the green. So this here, that there is the vertical reflection over y. So because we're reflecting over y, our y-coordinate, I should say our y-intercepts, that's a better word. Our y-intercept stays the same. Our x-intercept swap sign. Being that it's the same with the turning point. So the y-coordinate of our turning point is the same. The x swap sign. And it is the opposite with our reflection here. This is our reflection over x, which is a horizontal reflection. What will happen is our x coordinates, particularly the intercepts and turning points, stay the same. Our y coordinates of our intercept and turning point swap signs. And we can use this to graph things much easier, and that's exactly what you'll notice we happen with these three reflections that we had here. So that's just a little overview on reflecting over the y-axis and the x-axis and how it impacts and changes the x and y coordinates.